Hello everyone, I'm Paul and today we're solving problem 1865, finding pairs with a certain sum. This is medium and here I will show you my thought process and solution. So let's start. Our job here is to implement the FunSumPairs class. In this data structure we are given two integer arrays, nums1 and nums2, and we need to add support for two queries, add and count. Add takes two arguments, index and value, and here we need to add the corresponding value to nums2 at index. And count has one argument, this is total or tot, we'll call this target, and here we need to return the number of pairs between nums1 and nums2 for which the sum of the elements in the pair equals to the target. Let's say this is nums1, this is nums2. Now let's say we call add with the index 2 and the value 5. So we need to take nums2 and here we need to take index 2, meaning this, and here we need to add 5. So this 5 is now 10. Now let's say we call count with 7. I will put the indices up here. Here we can take this pair, this pair, this pair, or this. I will write the pairs here. So in this case we can take these 8 pairs. For example, 2, 2 is this and this. The sum between these elements is 7. And 7 equals our target. So if we take 3 and 2, for example, this and this is also a valid pair. 5 plus 2 is 7 and the target is 7. So when we call count 7, here we have 8 valid pairs. So we return 8. We will start with this query, count. Now the question is, how can we get count in a reasonable time complexity? Because maybe you're thinking about iterating every possible pair here with the nested loop. But the problem is down here in the constraints. This requires time complexity of 1000 times 10 to the power 5, and this is too much. We need to think about something more efficient. The strategy here will be basically the same as a very well-known problem called choosesum. If you don't know this, don't worry, here I will show you how this works. First we'll take the array with the larger length, meaning this, nums2, meaning this. And from this we will create a frequency map. So we iterate this from left to right, from index 0, and first we have 1 with a count of 1. Now we have 4 with a count of 1. Next is 5 with count of 1. Next is 2, so we add 2, 1 here. Next is 5, so now we have 2 5s. Finally we have a 4, so now we have 2 4s. Now remember that some element at nums1 plus some element at nums2 should be equal to the target. So we can clear n2 here, and n2 equals target minus n1. So now we can just iterate nums1 and check if we have in our map target minus each element in nums1. And if we do have this in our map, we can add to the result the corresponding count for that element. So we iterate this from left to right from index 0, so the I pointer is here. Remember we are calling count 7, and we start here from index 0 at nums1, and right now we have a 1, meaning we need to look for some value in the map, and this value is 7 minus 1, meaning 6. So now we are checking if we have a 6 in the map, and we don't, so we continue. Now the I pointer is here and we are looking for 6 again in the map, and we don't have a 6 here, so we continue. Now we are here and we are looking for 7 minus 2 in the map, and this is 5. And we have a 5 here in the map, so we add to the result these 2. So the result is currently 2. So what this means is the following. We have this valid pair and we have this valid pair. Okay, the count for 5 is 2, meaning we can take the current element and each of these 5 and create 2 valid pairs. That's why we add 2 to the result. Now the I pointer is here and we are looking for 7 minus 2 again in the map, and we have a 5 in the map, it's here, so we add 2 more valid pairs to the result. So the result is now 4. Now we are here, we are looking for 5 in the map again, we have the 5 here, so we add 2 more to the result, this is now 6. Finally we are here, so we are looking for 7 minus 3, this is 4. And we have a 4 in the map, it's right here, and it has a count of 2. So we add 2 to the result, this is now 8. Remember, what this means is this is a valid pair, and this is also a valid pair. So now we reach the end, and we have 8 valid pairs, so we return this. And with this approach, we have reduced time complexity from big O of n1 times n2 to big O of n1 plus n2, which is much more efficient. So now we know that in order to do this, we need to keep track of the frequency of the elements in nums2. So whenever we call add, we need to update our map also. So let's say we call add with index 2 and value 2, meaning here we need to add 2. So this will be 7, but before we will subtract 1, 5 from our frequency map. So this is now 1. Now we will add 2 here, this is now 7, and now we will add this to the frequency map. So we don't have a 7 here, so we add 7 with a count of 1. This entire operation requires constant time big O of 1, so overall time complexity for this entire problem will be big O of n1 plus n2, and space complexity will be the same. So now let's go with the code and hopefully you will get the idea. We are given this initially, so let's remove this and we start from here, and first we'll say self.nums1 equals nums1. Similarly, self.nums2 equals nums2. Now we will create the map, we will call this map2. So self.map2 equals default dictionary with a default value of 0 for every key, so that's why we use the word int. And now we need to fill this frequency map, so for n in self.nums2, self.map2 at the current number plus equal 1. Now for the add function, remember we need to add the corresponding value to the value in the corresponding index. So self.nums2 at the corresponding index plus equal the corresponding value. Now before this, we need to update the frequency map, so self.map2 at self.nums2 at index. We subtract 1 from here, then we need to add the corresponding value to the corresponding element, and then we need to add to the frequency map at the new value a 1. Now for this last query, the count is 0 initially and we need to return this count. Remember, this is the amount of valid pairs. Now we can say for n1 in self.nums1 current, meaning the value we are looking for, is total minus n1. And now we need to check if we have this value in our map. So if current in self.map2 cnd plus equal self.map2 at current. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.